And good morning, good afternoon, good evening, depending where you are. And thank you for joining us today for the ColorMetrix webinar, Your Color Toolbox Solving Process Control Problems with Gray Balance. Whoop, too fast. My name is Jim Raffel. I'm a co-founder of ColorMetrix, and I like to say I'm the Chief Color Officer. And I will be the only presenter today. So if you have questions as we go, if you take a look at your GoToMeeting control bar, there is an area that says questions, and you can pop that out, and you'll be able to type your questions in right there, and I will see them. I will probably not look at the questions until I complete this part of the presentation, and then I'll take a quick look at those questions and see if I can answer some right away. And some I may choose to follow up with you individually via email or phone. And then when we're done with that question portion, we will be doing the software demo, which, as I've said before, will not be recorded. So if you've used GoToMeeting before or GoToWebinar, no need to raise your hand. I'm not going to be entertaining questions that way today just because of the time limitations. But we can always set up one-on-one meetings if you see more interest as we go through. So this is what my color toolbox looks like. This is actually a picture of my desk. It doesn't always look like that. But I've got several things that are part of my toolbox of color verification and color process control. And if you kind of just look from the upper left, there's a color calibrated monitor up there, an ISO in my case. As you come down inside the little toolbox, there's a loupe, a very high magnification loupe, a Pantone book, the calibration plaque for my I1 spectrophotometer, a light booth. I have a small light booth right here in my office so that I have proper viewing conditions when I need them. The actual I1, my older I1 spectrophotometer, I have a newer one now, and then another measuring loupe. So those are just some of the tools. There's also software, which you can't see here. These are just some of the tools. I have others. So anyway, what we're going to try to do today is to take you through a process, at least at a very high level, that would allow you to make sure you always produce the right color every time. So if you look at these three red boxes we have at the bottom of this slide, one of them is right. I don't know which one's right, actually, but let's just assume that one of them is right and the other two are not right. And if it was, say, like a soft drink red, it's probably the one on the left, but the other two might be true examples of how some people sometimes reproduce those colors. And obviously when they do, they get in trouble with the client and have to rework and things like that. So we're here today to show you how to use some of the tools in your color toolbox to get the correct red or the correct color every time, all the time, on any device. All right. One of the things I like to point out to people is that as great a tool as the human eye is for color verification and even color process control, it's flawed. And we're going to prove that to you in just a second. But before I give you the answer to the question I'm about to ask you, I just want you to all look at this image, and I want you to focus on the box titled A, with the letter A in it, and the box with the letter B in it. And then I'm going to pop up our first poll question of the day. And that question is going to be, are the squares, oh, I think I have to launch that, hold on. All right, are the squares A and B the same? In other words, are they the same color? And I think some of you have been to my webinars because the answer breakdown is much different than the first time I used this one. So welcome back to you who are choosing to return. I appreciate it. And I'm going to give about another 5 or 10 seconds here. It looks like almost everybody who intends to enter their poll question has. All right, so let me close that and I'll share it with you. So, and for some reason, I'm not seeing the results. I hope you are. The answers were 63% yes and 38% no. And it was probably reversed last time I did that. And let's find out who's right. All right, so all we've done here is we've taken a mask and put it over the images, and you can see that A and B are actually both the same. And I've chosen a gray on purpose because obviously the subtitle of this is with gray balance. So grays are a very, very tricky yet a very important color in the color process control game. So basically, when you look at these and I'll go back. You can see they look entirely different, and it has to do with the boxes surrounding each of the A and B, and then also the shadow cast by the big green cone. But when we put a mask on it, sure enough, they are the same color. So this is just an illustration to show you that you can't always trust your eyes when it comes to color, as good as your eye is at evaluating color. So instead, what we recommend is that you invest in an instrument, a measuring instrument like the one shown here. That would allow me to measure those two grays or these two reds and get a definitive number that tells me how different the two colors are. And it's a number referred to as delta E that you may or may not know about, and that's a whole different webinar. But it basically allows me to measure these color swatches, whether it be the reds or the grays or any color, and determine whether or not those are the correct color, and if they're not the correct color, how far off they are. And that's why it's important that you have a measuring instrument. That brings me to my next question. How many of you own a spectrophotometer? We've got a couple choices here, yes, no, and I'm not even sure what it is. So I'll give you guys a couple seconds to answer that one. And this one's really more for my information. It helps me tailor the rest of the presentation to fit more with what my audience has. And I'm not too surprised by this answer. I'll tell you right now that more of you do than don't. And that's, again, that's a huge shift from when I started doing these educational webinars about 2 years ago. I'm going to give you guys just another second or two. And I'm pretty sure everyone's answered who wants to. So about 70% of you have instruments, and 20%, 30% don't or don't know if they don't. That's literally almost the exact opposite of what we had about a year and a half or 2 years ago. So I think these educational webinars are working, and or you've bought the instruments and you're continuing to attend, and in either case, that's a great thing. So you're doing yourself a great service by having an instrument available. All right, so let me get back to, here we go. So what does that instrument do, or what does our eye do? And the most important thing for you to know is that the instrument simulates what our eye does. That's the whole point of the instrument. We want it to perform like our eye does under the best of conditions, and that's the key word. We want it to mimic our eye under the best of conditions when we're not tired, and under the correct lighting, and without, with the correct illumination, without shadows. All of those things that you've already seen can fool you and confuse you when you're looking at color. We want the instrument to simulate the ideal. And in the ideal, we have a light source like the sun. We have objects like our two green boxes here, which we can see, at least on my monitor, they're not quite the same. And because we have good illumination, and because we're well rested and our eyes are fresh, and we don't have color blindness or anything like that, you can see the two boxes in his brain are still the same color. So this is what we're trying to simulate. We're trying to simulate the human eye at its best. That's what an instrument is supposed to do. So let's make sure we understand the eye a little bit more. This is what your eye looks like, kind of a cross section. Your part of your eye you see through is up at the top, and so your eye's kind of on this would be if you're lying down and we looked at a cross section of your eye. At the very back of your eye, and actually all around the inside of your eye, is the retina. So inside of the retina you have rods and cones, and the rods are for detail. So the rods see primarily black and white or grayscale, and the cones see color. So obviously it's the cones that we're most interested in when we're looking at color. The rods are obviously important when we're looking at grays, but gray is also a color. So we need a combination of rods and cones when we're looking at anything to evaluate it strictly based upon color. So there's this area in the eye called the fovea. And the fovea is almost all cones. It's actually where the vast majority of the cones in your eye exist. So when you look at color, it's very important that you look at it with the right angle. And that's why light booths are manufactured the way they are, and why you're supposed to stand straight onto the light booth and look down at it, because that's causing the light to come into your eye, and the vast majority of it hit your fovea, where you see color most accurately. It's also why our instruments are manufactured in what we call a 045 geometry. It simulates the eye. That light that comes in at 0 degrees is the light we see color with most accurately. So what kinds of things cause your eye to not work as well as the instrument? And I've kind of given a couple of these away. One is your eye frailties, fatigue. As you get older, or even if you're young, I used to do color OKs in my early 20s, and I was the young kid on the block, so I got all the 3 a.m. color OKs, and I didn't really mind those, but at 3 a.m., even young eyes get tired, and you don't see color as well as you did at 8 in the morning when you got out of bed. Memory colors can be very confusing to the eye. If you know when I say the words Coke red, I'm pretty sure that in most of your heads you can almost see Coke red. And if I showed you a color that wasn't red enough, or you could probably tell within a certain delta E tolerance better than other colors. So your memory can be both good and bad for color. It can fool you into thinking you're seeing something you're not sometimes. Because if you look at a couple of years ago, Coke redid the can for the holidays, and they kind of reversed the colors and basically made the Coke can look like a Diet Coke can, and it confused everybody. People were buying the wrong product, and they pulled it actually from the shelves and stopped production because of it. And it had a lot to do with memory colors. And I wish I still had pictures of those cans. I think Shelby does, and we might add them to this presentation. So color blindness, for the women on the webinar, don't worry about it. It's literally almost a complete non-issue with women for some reason. But in the male population, it can be as high as 8 or 9, 10% of men. And one of the colors that we do see well, whether we're colorblind or not, is blue. And I will tell you that the founder of Facebook is colorblind, and it's why Facebook is predominantly a blue website, because he could see it. And by doing that, also, pretty much all men, whether they're colorblind or not, can see sites like Facebook. So sometimes when people tell you to put your call to action on your website as a green button or a red button, not such a great idea, because a certain percentage of your population can't see those colors well, whereas blue they can see quite well. And I think if you look at the emails we send out, our calls to action are almost always in blue, and that's why. So that's a little off the beaten path of this presentation, but interesting information nonetheless. Adjacency, we've already shown you that was why the A and the B did not look the same. It's because of the colors that were around the colors we were looking at. Age, I turned 50 this year, and I can guarantee you I don't see yellow as well as I used to see yellow. Just for some reason, women seem to see yellow well all their life, but for men, when our eyes age, we don't see yellow as well. And as a result, when there's yellow involved, I try to have a woman or a younger man look at the color with me, and or I measure it with an instrument, because I don't know if I can trust my eye anymore with certain, especially light yellows. It gets harder and harder to see. You can help some of that with the viewing conditions. Bad viewing conditions, bad color. Good viewing conditions, good color, basically. It's amazing what a good light booth will do to allow you to see color more accurately. So let's talk about what color actually is. Color is basically, it's a sensation. So it's something that happens in your brain, and I went back too far. And it involves all the things we talked about in that other image. So there's that light source, which is the sun, or in the case of a spectrophotometer, there's some kind of a light source inside. There's an object that you look at, so that's reflecting the light back. And then there's the receiver. So in the case of your eye, it's that fovea, it's the back of your eye, and then your brain. And then there's also, in the case of an instrument, there's a bunch of electronics in there that take the light, receive it, and turn it into some kind of color information. So if you look at this one, we've got the sun going through a prism, and we're breaking it up into red, green, and blue, and that's because white light is made up of many, many colors. So white light is a example of additive color. When I take the red, the green, and the blue, like think of your monitor, it's got red, green, and blue diodes, or back in the day they actually had guns and the CRTs, and then now you've got the LEDs. So there's red, greens, and blue, and it's the combination of how you turn them on. When you turn them all on, you get white, which is in the middle, and when you turn on combinations, you get the whole rest of the spectrum. But the key is that you're starting with black. If I was to turn off my monitor, or you were to turn off your monitor, it would be black. And then as we add color to it, that's how we see. So that's why we call it additive color. So we start with black and we add color to it until we have white. What's interesting is we print exactly the opposite of that, yet we try and look at color on our monitors. And it can be done, but it requires you to gray balance both your monitor and your press. And the G7 method we're going to talk about is one way to do that. Your printing process is subtractive. So you start actually with a white sheet of paper typically, but you start with some kind of a substrate, and then you put inks down on top of that. So all the color is there on the sheet. And by putting different inks down, and you can see what happens here. When I put my cyan, magenta, and yellow all down, I get a muddy brown. I don't get black. And that's by the way, why we have black in our printers, is because the three colors together typically does end up in some kind of a muddy brown. With some printers, it's closer to black than others, but it's typically never as black as a black ink by itself. So we're actually using black to make up for deficiencies in our three process inks, and we're also doing it because it's cheaper than printing with three colors. So we start with the white, and as we put the different colors down, we either get black or some combination thereof, and that forms the entire visual spectrum or the gamut of your device. All right, time for another poll question. So if you look at this slide, there are it's one image. There are three iterations of one image at the bottom of the slide. And we've kind of given the answer away. So for those of you who know what's going on here, you'll be able to figure it out. But my question is, are those three images the same? And I'll give you guys a second to answer this one. Okay, you guys are reading the slide. I'm impressed. And or you've all been to my webinars before, or you came by the booth at SJA and we talked about this. So, all right, I'm going to close this off and I'll show you guys. You all got it right. They are the same. They don't look the same though, and that's what makes this interesting. So what this light booth does is it illuminates three copies of the same image with three different light sources. So store light, like you're going to see in your retail store, daylight, like you're going to see outside or in a D50 light booth if you use one, and then incandescent, which is what we might still have at home, although more than likely, unless you're like my friend John Sweeney, who admitted to stocking up on incandescent bulbs because he likes them, most of us are probably not going to have incandescent in our homes for much longer. But it does show you how different it can be in the problems you encounter, because the one in the middle here, the daylight fluorescent, is what we use in our printing plants typically. If we have a light booth at all, it's going to be this light source here. And yet in the store, it looks like this, and yet the customer gets it home and it looks like this. So how do we solve that problem? Well, we have to have a light booth, first of all. Have to have a light booth, and here's an example of one. And then many of the modern light booths allow you to not just look at product under a single illuminant. They typically have some switches where you can change between 2, 3, 4, 5. There's actually LED light booths out there now that allow you to set a custom white point if you want to. So the key is to have a light booth that can simulate the viewing conditions that the product is going to be viewed in the real world. But we still have another problem, and that is that, as I mentioned earlier, our designers create on a monitor. So how can we create on a monitor which is additive and print on a press or an inkjet, wide format inkjet device that is subtractive color and have it be the same? Well, one of the ways is that we calibrate both of those devices, and there's all kinds of great software out there now for calibrating monitors. The newest EZO monitors actually have a sensor built right into the bottom bezel, so it can literally calibrate itself. And if I calibrate my monitor and I calibrate my press using something like the G7 method and an ICC profile, believe it or not, I can get it so that my monitor very, very closely simulates what I'm going to print. And if you're in the digital sign business, the wide format sign business, can you imagine having a customer walk in your shop and you have a color calibrated monitor right there on the front counter? They give you the file that they want you to print. You load it up and you bring it up on the screen and you say, this is how it's going to look. And if they go, well, no, it's not supposed to look that way. It looked all different on my monitor. I'm sure it did, sir, but this is a color calibrated monitor that matches the way my printer prints, and this is how it's going to look. Do you want us to correct it? Do you want to correct it? And boom, before you've spent any money on ink and media, you've headed the problem off, and you can actually end up with a more satisfied customer and maybe a more educated customer as well. So again, the solution is to purchase monitors that are capable of being color calibrated. And there's some out on the market now that are well under $1,000, and they come with a device to do the calibration. And are those the best ones out there? No, but they're probably good enough if you're not doing anything right now. So for a relatively modest investment, you can see what you're going to print before you print it, as long as you color calibrate the entire system. So the other thing that seems to happen quite a bit is you produce a package and it's got prominent brand or spot colors, and the client rejects it. And that's one thing that happens. But the other thing that could happen is, let's say you're in the sign market and you're printing a sign that's going to go next to a stack of 12 packs, whether it be soda or beer. But you're printing that same brand, logo, and color on the pop-up sign or whatever the collateral is that's going to go next to the stack of 12-pack cases that were printed probably by offset. So you've got these offset printed on relatively inexpensive folding carton board, and then you've got this, this nice photo print or banner paper with a really bright white point and fluorescence in it and everything, and you need to match that brand color. And believe it or not, this is where a lot of rejections come in, because the brand rep comes in and looks at it and goes, "You missed my brand color." And now the reality is, whoever printed the folding carton might have missed the brand color. And the problem is, without you having your system calibrated and doing some measurement, you don't know if it's him or them. You just know, you're just standing there with the brand manager, and he's saying, "One of you got this wrong." And the reality is, it's easier for me to have you reprint that sign right now than it is to reprint these folding cartons. But if you can come to him and say, "No, I got it right, they got it wrong," now the reprint is on his dime, not your dime. So this is just another way that gray balance calibration can actually have a payback. Oops. So again, your solution is essentially a swatch book, and it can be a digital swatch book or it can be a printed swatch book. I recommend, when you get your printer to where you want it, you print your own swatch book. So it would be a swatch book with your printer calibrated the way you want it calibrated. And when a customer specifies a color, you find it in your swatch book, or you even print the swatch book for them and say, "Please specify one from this printout, because these are the colors we can really produce on a daily basis consistently and repeatably." But it's about having a swatch book, and you can't really have a swatch book that's useful unless you're printing consistently and repeatably every day. And if you are, then the swatch book you made 6 months ago, you can reproduce those colors today. So let's talk about the last, and that's not the last, but one of the other variables in the process that everyone kind of forgets about. So if you look at this color quiz, it's asking us which stocks are printed with the same ink. And we used to do a poll question here, and since it seems like many of you have been on a lot of these calls, you already know the answer. But for those of you that don't, that is all the same ink. Let me go back a slide though. So that's what happens. You've got to match that brand color. You're trying to match it on your photo print paper, and the printer or the folding carton might have been matching it on something like the one at the very top. I can't even read what it is, but it's a kind of a brownish white board because it's less expensive, and that's what the folding carton is made out of. And you're printing on something that's bright and white, and you could literally use the same ink and not come up with the same result. So to get the same result, you have to adjust your ink to get the same color. I know it sounds crazy, but using 2 different color inks on 2 different substrates will actually result and can result in the same color. Whereas here, we've drawn down the ink and they aren't the same because of the difference in substrate. Hopefully that's making sense to you, because that's a key component of any gray balance process. You have to make sure that the substrate that you're using is accounted for in the gray balance. So as you make gray balance calibrations, you have to make a different one for each and every paper that you have. So how does that work? Okay. The way that works, so now we're into kind of the meat of the presentation here, or really I should call it the answers to the questions I've been asking. You basically do a gray balance calibration, and you can do that with software like we're going to show, but there's other softwares out there. And if you go to the Ideal Alliance website, they have G7 certified tools. All of those can create what are called curves or G7 calibrations. The way that you do it is on the top here, well, in the middle of the page on the left, the top target, the top color target is our calibration target. We print and measure that calibration target, and based upon those measurements, we can create a set of calibration curves. As long as you have a RIP that's capable of importing calibration curves, you actually eliminate your RIP's linearization process and instead linearize to a known set of gray balance points. So one of them is the G7 name that Idea Alliance has trademarked. So they have a published set of references, and it's in a CGATS technical report. I think it's TR015-2013. And in that report, they actually publish these known gray curves that you're supposed to hit. The advantage is that once I hit this gray curve, I can hit it over and over and over again because I know exactly what it is. I don't necessarily know what my RIP linearizes my printer to, and I also don't know that when I relinearize that it necessarily brings it back to the exact same point. Gray balance calibration, on the other hand, does. It brings you back to the exact same point. So if my device starts to shift, which I do by measuring the second target down below, that's the verification target. If my device starts to shift, I measure my verification target, I get a fail. As part of that verification target in our system, you basically have already generated a new set of curves that you pull into your RIP, you remeasure this verification target, and you verify that you are back in spec. When I'm back in spec, I can produce those brand colors accurately again. All right, so how does that work? Let me give this a second to catch up here. There we go. All right, so if we look at these 6 images and focus on the 2 in the middle on both the top and the bottom row, those are simulated Grackle proofs. So Grackle is just a print standard. Again, we wanted some known target to try and hit. On the very top, left-hand side, that's the way that a Muto printer prints right out of the box. It's very, very oversaturated and very green. And that's somewhat dependent on the inks. They use someone else's inks, and those inks do the exact same thing on a different brand of printer. And some printers shift red and some shift blue, but they all shift and they all come out oversaturated. That's just the way that they work out of the box. If you use a RIP, you can linearize, which we're simulating in the upper right side. So there we have linearized using the RIP's linearization routines. And you can see it took care of the oversaturation, but it's still green. It's really green. On the bottom, on the left-hand side, using a G7 tool, and they're all going to give you a similar result, including the one we're going to demonstrate in just a few minutes here. This is a G7 calibration with the initial pass, again, compared to the Grackle proof, and then we can actually create these iterations I talked about. So I can send anyone who wants it. If you email me, I can send you a high-res PDF of this if you want to inspect it more closely. Some of you probably saw these prints at SGIA. I mean, this really does work. Now, when we get to that second iteration on the lower right and compare it to the Grackle proof, it is not a perfect match. I'm not trying to say it is, but you're probably 85 to 90% of the way there. And if it's not a good enough match, you can then put an ICC profile on top of that if you choose to. For many of you, this might be all you need to get consistent and repeatable color time after time, because you're not necessarily trying to hit a Grackle proof. You're trying to print consistently and repeatably time after time. All right, so my last kind of problem that I like to solve with the color toolbox is one of language. Creatives generally have a very different mindset and a very different set of terminology than those of us who run presses and run printers and actually produce finished product. And that's okay. It's a reality that we have to recognize. My favorite story, and I'll keep it short because I'm watching the clock here, is those 3 a.m. color OKs I mentioned early on in the presentation. Well, one of the first ones I did, the client came in and said, it's too cool. Can you warm it up a little bit? And I was feeling a little punchy and went out to the pressman and I said, hey, where's the warmer knob? We need to turn it up a little bit. And he just looked at me and laughed. But that's part of the problem is what does warmer mean to a pressman? What does warmer mean to an inkjet printer? It doesn't mean anything. It's not something we can adjust. Now, as imaging professionals, we know what they meant. They wanted a little more red, a little less blue. But if we all just talked that way, it might help. If we all used the same terminology instead of having to interpret, it might help. And one of the things you need to do is, buy a loupe for yourself, buy a loupe or magnifier for yourself and for your customer. So now when there's print problems, you can pull out your loupe and you can look at it and you can look at the dots and look at the print quality and together you can go, we're printing okay or we're not printing okay. And it stops finger pointing and it starts being a situation where we're going to all work together to solve the problem. So let's see if, actually, I want to ask you guys one more question before I show you my last two slides. Have you ever heard of the G7 gray balance process before I talked about it today? So I'm really asking about, before we started up this webinar, had you heard of the G7 gray balance process? This is great. It looks like the vast majority of you have, which is good. And I'm guessing many of you will probably stick around for the software demo because we have a tool to do that coming up here in just a minute. All right, that's good enough. So about 80% of you have heard of it, and that's great. And for those of you who haven't, I'm glad that you took the time to learn today. And hopefully you'll stick around and learn a little bit more about it in just a minute or two. So I've got a couple more illusions, and then I'm gonna stop the recording, and we're gonna do the demo that you're all anxiously waiting for. So, you know, I'm not gonna do a poll question. It's a rhetorical question. So can you trust your eyes? Are these two grays the same? And when I say these two grays, it's where the little red arrows are pointing. So are those two grays the same? And yes, they are. That's what we took that gray bar and we drew it between them. There's a little gray line we drew. And if you have really good eyes, you can see that they are they're both 127, 127, 127 RGB. And that we fooled you again with surround. And even if you knew they were the same, they don't look the same. And we did it again with the surround. You know, you get that brown kind of carpet or whatever it is, corkboard and blue sky, and makes the two grays look entirely different, even though they're sitting next to each other. Oh, and of course, there's that little black line in between them to fool you too. So, all right, so this is how we solve color management problems with the tools in your color toolbox. You obviously probably all know how to get a hold of me already. ColorMetrix.com is a great place. That's where this webinar will be once it's recorded. I'm under the webinars tab. You can always talk to us on Twitter. I mean,